Okay, does it look like that? Sorry, because the curve look like that. Maybe that point is a little bit here, no here. Okay, this is not important. The important in the graph was to understand the problem, no? Now, what's the formula for the exponential growth? Exponential growth formula is population at any time is equal to P null exponential e to the kt. Interpretation P null. What is P null? No, P null is the initial population. In our specific example, 500. However, what about K? K is similar to the financial problem interest rate. It's a quantity, it's a number that indicates us how much fast increasing the exponential. And T is the time, in this case, the time in years, okay? So basically, my formula starts like that. Population at any time, we can model, it's a mathematical model, 500 e to the kt. But K is not given in the problem, no problema, because we're using the condition 1 in which we have everything, the time, and the amount of the inset to find the K. Okay, so if you evaluate at T equal 10 days, is population at 10 days. By the way, is 611. This information is given 500 e to the K multiplication by the time que corresponde with the condition to stay. So actually, in this moment, we have one exponential equation. Let me rewrite this. 611 is equal to 500 e to the 10k. I changed the order here because normally the coefficient you put in the front, no? It's more elegant. Now, what is the only unknown we have in this problem? K. Okay, it's not the final answer. K is a partial answer, right? Okay, but no problem. We apply logarithm. What kind of logarithm? Well, either. However, in my opinion, it's much better apply ln. Why ln? Because ln is natural. I know that the base is e. And so now when you, well, first of all, you divide by 500. Both sides. So 611 divided by 500 is equal e to the 10k. Now ready to apply logarithm of both sides. When you apply logarithm of both sides, ln of 611 over 500 is equal ln e to the 10k. Does I remember the property number 4? I guess so. Property number 4. Okay, is look like that. The logarithm of the any arbitrary base of the one exponential is equal x. In other words, it's like a logarithmic function and exponential function cancels out each other. And this is normally because they are inverse functions. Specifically, in our example, is no arbitrary basis, is ln e to the x is equal x. Actually, the answer of that part is just 10 to the k. It's like a ln and exponential cancels out. Do you understand this idea? Finally, natural logarithm of 611 divided by 500 divided by 10 is equal to. And k is not the final answer. No. But it's the partial answer that help me to continue the problem. The problem is complicated. The problem has two parts. So everyone now use the calculator. I want to indicate how to use the calculator. Okay. I have the calculator in my hand exactly like you see in the whiteboard. Okay, I clear the display. Nothing. I put LM. So now this is my display. I try to explain. Be careful. Try to follow me. you put ln parenthesis. When you press that key, you press that key, that key. When you press that key, we have ln parenthesis, good. And you put inside 611 divided by 500. And press close the parenthesis. I typing in my calculator 611 divided by 500 and close the parenthesis. And division by 10. And division by 10. And division by 10. Then press enter. You get the answer, but I don't copy this answer. No, this is K. Okay, I saw on the display something like that. You want to copy in the piece of paper? No. Because this is not the final answer. No good. It's 200488886. Maybe some students say, no, well, okay, I copy in the piece of paper. I trunk it or round off for decimal place, no problem, I continue. No, well, okay, you can do that. However, much better, in my opinion, is you store this number inside your calculator because the calculator have memory. Okay, so then this key, look, this key is called storage. You press storage key, and immediately you can see in the display of the calculator, at least in this calculator, another calculator is different, is the different memory we have. This A, B, C, and so D, E, and E. And this number gets 0.0000, 0.02. Because when you press enter, to see the answer. You press enter, you press store key, and you press enter again. And the action of this enter is you assign, in this case, I highlight A memory, maybe, or B, whatever. You press enter. Now you see in the display something like that. Answer, arrow A. And you press enter to confirmation this command. Boom, and that's it. So actually, the letter A inside the calculator is K. Is the K number. And we continue the problem. The rest of the problem is super easy because in this moment, we come back to the original equation. If you want to rewrite it, is population to any time is equal to P null, que 500, E to the KT. But now I know what is K. K is that number I have inside the memory of the calculator. So you copy in the piece of paper and you typing again, no? But I recommend using the memory. Because I need 30 days. So population of 30 days is our final answer. Is equal to 500 E to the K times 30, no? How you typing this in the calculator? You see how. Again, you clear the display. You put 500. Multiplication time E. Remember the key exponential is the same key of the logarithmic, this key, look. But you press first, second, in blue color or in yellow color, depende del calculator, no? You press this, E, and you see something like that in the display. E power something. Entonces power something is K, pero K en our calculator is A, and you in order to retrieve this memory, you press in the memory bar Memory bar, wait. Record. Memory bar. You press memory bar. Of course, you select A. Entonces you have in the display right now, you have A. Okay, A actually is K. Multiplication time 30. And close the parentheses. Boom, I get the answer. The answer is 912.39 something 6524. Es obvio que in our problem talking about inset and have no sense to talking about decimal inset. So the answer is 912 inset. Okay? Was clear? Was confusing? There are many ways. Suppose that you don't understand very well the memory of your own calculator, que is different to this calculator. Okay, no problem. You copy this in the piece of paper and you substitution this number here. Doesn't matter. Maybe when you truncate, suppose you select only 0.02. The answer is very, very similar, except you lost some approximation, but no, it's no big deal. It's no big deal because finally you don't care the decimal value because we are talking about inset. Entonces now have no sense to talking about decimal of the inset, no? Any question? Any question? What part you don't understand? This is a no super complicated, but this is the most complicated problem que involve two stages. One stage is using condition 1 que help me always to find the K. The K, remember, is like the rate of change of the exponential. So it's a number que indicate how fast increasing in that case exponential. Okay? Any question? Any question? Confused and clear? Mr. Holmes, you always ask me something when you don't understand. I appreciate so much this. You got the idea or no? Clear for now. Okay. And the rest of the students is okay? Okay. Let's move on. Let's move on. Let's move on to the next problem. Application. Very, very strong, big application problem. This was talking about biology. Next is talking about chemistry. It's a little bit chemistry and archaeology. Let me see the next problem. Archaeology. Because it's about, there you go, it's this guy. Okay, there you go. Is the traces of burned wood along with ancient stone tools. Suppose case archaeology discover the ancient stone tool, and this ancient stone tool contain wood, but this wood was burned. Now there are different techniques to determine the age of this piece. The most important test is the test of the carbon 14. Okay, carbon 14 is isotope. Carbon 14 test is like unstable isotope. And this isotope disintegrate. Isotopes disintegrate. So this is the atom and disintegrate in another particle, and this become in another compound, no carbon element, no carbon 14, another. So study the amount of the carbon 14 isotope que stay alive. You can compute a little bit certainly approximation the age of the one thing. Using one concept que is the half-life. Half-life. What is half-life? Suppose at the beginning, okay, in the 1,000 years ago, we have 100%. This is the time, but this time now is in years, not in day or minute, because this process is too slow. Entonces now I need to understand what is the idea behind half-life. You suppose in one time t equals 0, we have 100%. 100% of what? Of this element. During the time, this element, isotopable, unstable, disintegrate according to the exponential decay. Exponential decay. What is the idea behind exponential decay? It's also another exponential. And the formula is very, very similar. For example, amount of substance to any time, I call no P, because P population, A is amount. A null, E to the KT. What's the problem? It's the same formula, professor. No, because in this case, K is negative. You suppose at the beginning just K. You know, when you compute a K, I guarantee you that you get negative number because it's decreasing function. So this curve is decreasing function. So now, when you're talking about the half-life, what means half-life? Half means 50%. 50% occur in this moment, que is 5,600 years. This is for the carbon-14 test. So I need to, I don't know, so you analyze, in this case, we have, look, the concentration of the carbon-14 is 1.67%. Wow, it's too small. So that means 0.67%. That means that this sample is very, 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 very antique. Look, I need to determine this amount of years. So we have condition 0, always, because at t equals 0. Condition 1 can help me always to find the k. And the condition 2, in this case, a little bit different, because in the previous problem, we have the time, and we need to find the amount of inset. In this case, different. I have the percentage of the carbon-14 present in the sample, and you need to find it. It's a little bit different, but it's similar procedure. Okay, so now we have the formula. I suppose at initial, A null is initial, is 100%, expressed in relative units. So say we have A anytime is equal 100% E to the KT. But you don't know K. K you can find using the half-life. Let's see how. Okay, now half-life is the condition 1 here. I know it's 50% of the carbon-14. 100 was at the beginning, T equals 0. And the duration of this long process is 5,600 years. So you have K multiplication by 5,600 years. Wow. So now I have again, one more time, exponential equation. Let's do it. Now you divide by 100 both sides. Because my intention is isolate the exponential, no? And 50 divided by 100 is 1/2. Oh, this is the reason that 1/2 life. Look, 1/2 is equal E to the 5,600K. Okay, one more time. We apply natural logarithm. It's the most convenient logarithm to apply because the base is E in the exponential. You can apply another. Yeah, you can, but no. It's much better apply ln. ln 1/2 is equal ln E to the 5,600K. And you know the property number 4. Okay, this is cancel out each other, right? And this is 56 100k. Because logarithm and exponential undo each other. Now k alone is natural logarithm of 1/2 divided by 5600. And it's k. Okay, one more time. I use my calculator. Let's do it. I encourage you try to verify my calculation. Okay. Okay, I need to compute that. And why no? This is not the final answer. Therefore, I store this information in the memory. And don't worry, you select another letter A, B, C, D. Or so you assign the same letter automatically. The value is replaced in the memory you select. Okay, so, and this is my display. My display. I press one more time the key natural logarithm here. And so we have the display of the calculator, something like that. Let me try. Elaine. And you put 1/2. 1 divided by 2 and close the parentheses. 1 divided by 2 and close the parentheses. And division 5600. Division 5600. Bam. And you get super small number. And by the way, it's negative. It's negative 0.00123776. This is the number I saw in the display, no? Okay, now I know that this is not the final answer. I understand two things. Number one, k is negative. And k is negative because we are working on one problem of the exponential decay, in which the exponential is decreasing, it's going down. K is negative. See, k is positive is exponential growth, increase. Okay, I store this information in the memory. To store in the memory, it's easy. One more time we are doing. I press the key store. When you press the key store, automatically and the display visualize different memory. Okay, I don't care. Now I select A, maybe, or B, whatever. I press enter. Yeah, I saw something like that in the display. Answer, arrow, A, because I select the same. And the number gets this number. I want to store in the memory. Press enter to confirmation of the command. Boom, and that's it. Now in A we have K. K negative. Okay, now in order to finish my problem, I come back to the original equation, is this. Amount of substance to any time is equal. Initial is 100 e to the kt. The difference is now I have k in the memory. The initial of the amount is 1.67. It's the concentration of the carbon 14 in this time. Now, this is now, present time. 1.67 equal 100 exponential kt. In my goal is solve for t because I want to determine the age of this event. Okay, solve for t. Solve for t. Now divided by 100 on side. Same routine. Okay, we have 1.67 over 100. Don't touch this. Now exponential kt. Now apply logarithm. What kind? Again, natural logarithm of 1.67 divided by 100 is equal, you know, is kt. I don't want to repeat again. Well, okay, the natural logarithm e to the kt is kt. Final t is my goal is divide this by k. And remember k is that number. Okay, by the way, we have inside the memory of the calculator. Divided by k. Let's do it. And this is the time. que represent the age of these antiquity tools. Okay, I clear everything. This is my display now, totally clear. Okay, now I press one more time the key LN. Okay, I do that. LN of what? Of 1.67 divided by 100 is 1.67 divided by 100. Close the parentheses. Guys, this is important. The parenthesis is super important in the logarithm, right? Because it indicates us what exactly is the argument inside the bracket. Divided by K. But K in our problem is actually A. I press A. How you press A? Well, now you press in the memory bars. K actually means memory variables. You press this and you see the collection of the memory bar. We are working only with the A. So it says memory bar, A, bar, and present the bottom. And I copy the answer. The answer is 33062. So let me see. The answer I have in my paper. Oh, yes. 33,062 years. You truncate it. Because it's a super fantastic approximation. This is the age of these antiquity tools that they are archaeologically found and using the carbon-14 test. And one application in, it's archaeology and chemistry about the using logarithmic and exponential function. Any question? What part is confusing? Come on, opinion. I am willing to explain everything together again if you want. Everything okay or no? Opinion, guys. Mason, tell me. It's too long. Sorry, this is called algebra. It's not hard, but it's long. Okay. Don't expect I got the problem here with me. Okay? This is just the beginning of the mathematics of the college. Clear. I promise. Listen to me. I promise in the test of this subject, I don't put no too complicated problem. I put easier or relatively easier or not too long. You see in the review package. Okay, maybe we start in a few minutes. Okay. Okay. So see, everyone is agreed. See, everyone understand the basic idea. Of course, I present the idea. And now we need to practice more, no? In the review we practice, and the Alex we practice. Another problem. I encourage you that when you don't understand anything in Alex, you email me or visit to the tutoring service. Tomorrow in the morning, in the afternoon, we're working in the tutor, all from 11 to 5 p.m. Okay, let's move on to the last problem. Okay, it's about the Newton. Let me erase the board. Newton cooling law. What is that? I want to explain that. This is physics, typical physics problem. Okay, it's a transfer of heat, cooling process. Okay, let me go to the PowerPoint. Application logarithmic. Okay. Come on, this one. Insert that page. Is Newton law of cooling formula. I want to explain, but I want to explain another formula. This is the image that I get in the internet. Okay, what is the idea behind Newton cooling? It's easy. You have one object. Suppose a pizza. One object. Suppose pizza. This is the cheese. And this is a little bit pepperoni. Pizza hot. And this pizza is very, very hot. Half the temperature 400 Fahrenheit degree. And you withdraw of the oven. And immediately the heat is transferred. And the temperature decreases. But decreasing to what value? Of the temperature of the environment. This is a room. Room supposed to have air conditioner, and the temperature is supposed to be 70 Fahrenheit degree. Entonces, the graph of this look like that. This is time. This is temperature in Fahrenheit degree, maybe, or in Celsius degree. This problem is Celsius degree. Doesn't matter what degree. And the beginning at t equals 0, the pizza have 400. However, the temperature decreases, but decreasing according to the Newton formula. Okay, I want to explain in a few minutes. Let me try to understand the physical idea. And decreasing, but decreasing to 0? No, no 0, no. To the temperature of the room is 7. This is the final temperature. And we have two magnitude important. Magnitude important is initial temperature, I, 400, and final temperature is the temperature of the environment of the room. And so what is the formula? What is this formula? Well, this formula is temperature to any time is equal Newton formula, final temperature plus initial temperature minus final temperature e to the kt. This is the formula that we are using. Okay, in our specific pizza problem, final is 7, initial is 400, and K again represent the real change of the exponential. So ese parámetro que indicates how fast, in this case decreasing because it's cooling the temperature. So it's negative. K is negative again. When you see decreasing, it's negative always, anytime. And this time. The time can normally in this problem that we are read now to understand is in minute. Look at that, minute. In minute. So the time is expressed normally in minute. Okay, remember in the first problem, the time was a day. And the second problem, the time was in years. And this last problem is a minute because the event is faster. Okay, do you understand the idea for the Newton law? Let me copy the equation. Let me copy just the equation. I want to erase everything except, well, the equation I rewrite again. Okay, good. Delete. Oh. Delete. Good. Let me come back to the problem. This equation is the equation that I see in the image, very similar to my equation. My equation, in my opinion, better is temperature to any time is equal T final. They call T null. No, I don't like this. The null is T equals 0. No, the final is T equal infinity plus initial temperature minus final temperature. Final temperature final. Temper final, okay, by the way, is the same. This is the same. E to the kt. They put negative. I put positive because the negative is coming when you solve the problem. You tell me k is a negative. So this equation is good, but no, I don't like it. Okay. Now we have object gets heated to 100 Celsius degree. This is initial temperature. 100 Celsius degree. And it then allow it to cool in the room whose air temperature is 30 Celsius degree. This is the final temperature. It's a classical cooling process. Look, decreasing temperature. if the temperature of the object is 80 Celsius degree at t equals 5 minutes, when the temperature would be or be 50 Celsius degree. Let me try to understand. We have a lot of temperatures in this problem. Wow. But Professor, you explain only initial and final, and we have two more temperatures. Ah, well, okay. Let me try to understand the problem. In my opinion, I respect another opinion. The best understanding of the problem is doing the graph, in my opinion. Some people say, no, I never understand this story. Okay, at t equals 0, this object have this axis temperature in Celsius degree is 100. This is the initial temperature. The initial temperature. And es obvio que the temperature decreases. Pero decreasing asymptotically to the final temperature, que is 30 degrees. This is 30 degrees. Final temperature is 30 degrees. Okay. Asymptotically. Sorry, guys, this is a very common line. Okay, let's say horizontal line. All right, let me see. Let's do it again. It's a mess. It's a mess. Okay, using the rule, 0 degree. I suppose that this is 30 degrees. And the curve of the temperature, let me use a record, start here, travel for this, and approach it, but never touch. Why never touch? Because when the difference of the temperature is too small, the amount of heat transfer is smaller and smaller, and we never finish. This is the idea behind Newton. Okay, so now wait. This is asymptotically approach it, but never touch. The problem talking about the room is 30. This guy is 30. The final temperature is 30 Fahrenheit, not Celsius degree. Look, 30. If the temperature of the object is 80, one intermediate value is 80 Celsius degree. And this situation happened at 5 minutes. T equals 5 minutes. Entonces, in my mind, this is working like a condition 1. Condition 1, and this is condition 0. Okay, always condition 0 is the initial condition. And they want to know, and the condition 1 is always useful to find k value in any problem of the logarithmic exponential. I need to find for the 50 Celsius degree, it's the last temperature. What about at what time? B. This is my final answer, temperature, and the condition 2. Okay? Do you understand the idea? Okay, let's do it. Entonces, my formula is, I plug in temperature to any time is equal 30 plus 100, que es initial, minus 30 e to the k. Okay? Temperature to any time is equal 30 plus 70 e to the k. Because 100 minus 30 is 70. Okay, and this is my super important formula. And this is a specific problem. Another problem is another number. This problem, yes. Let's do it. Using the condition 1. Because allow me find k. How do you know? Well, because in the condition 1 you have everything. You have temperature and you have time. The only unknown in the problem would be k. Entonces temperature at 5 minutes, you evaluate here 5 minutes, is 80 degrees. Is equal to 30 plus 70 exponential k times 5. Okay, entonces in this moment we have exponential equation. The only unknown in this exponential equation is k. Okay, let's do it. It's easy. You're subtracting 30, 80 minus 30 is 50. 50 is equal to 70 exponential 5k. Divided by 70 both sides. It's obvious. It's obvious que we cancel out this 0. 5 over 7 is equal to exponential 5k. Now ready to apply logarithm both sides. Of course, one more time, use a natural. And you know very well that this is 5k. I don't want to repeat again this. Now, natural logarithm of 5 over 7 divided by 5 is k. And remember, k is important, but it's not the final answer. It's a partial answer that is stored in the memory of the calculator. Okay, let's do it. Calculator memory. I bring my calculator. I never forgot. Boom, here. Okay, this is the display. Okay, I type LM, parentheses, using that key. Again, I typing. Okay, on, clear. LM, LM of what? 5 divided by 7. 5 divided by 7. Close the parenthesis to indicate that the argument of the logarithm is done, it's finished, divided by 5. Divided by 5. After division by 5. Press enter, and you get exactly what we expect, negative value. Negative 0.0679, something like that, no? 29. At least in my calculator, 294477. You copy everything you want. Because you don't understand very well the memory, I highly recommend you copy everything. Okay, now, well, I press the store key because I want to save this number. Again, in the second memory, memory A, press enter, enter. But I have, in that moment, remember at least in this calculator, it's exactly the calculator I have right now in my hand. You see, and the display something like that. Yeah, I know that this number is recording or save or memorize and the A memory, inner memory of the calculator. Okay, let's do into the last part. The last part is we come back to the original equation, but what? The original? No. The specific for our problem. Que es 10 to any time is equal 30 plus 70 e to the k. And remember, I want to refresh your memory. You have the tempers, que 50 degree. Look at that here. I need to find the time associated with the temperature. So 50, I put here 50 is here 50 is equal 30 plus 70 e to the kt is solve for t. Let's do it. 50 minus 30, 20. 20 is equal 70 e to the kt. You divide by 70 both sides. 20 divided by 70 is equal e to the kt. Actually, this is 2 over 7, no? Because you cancel out that 0. Is equal e to the kt. Now I'm ready to apply logarithm on both sides. Ln of this is equal kt. For the same reason I explained before. Now t is my goal is ln 2 over 7 is equal k. Be careful. Because I say, wow, professor, but this is weird because K is negative. And the time, no, the time is always positive. No? Because the train travels in one direction. The time is always positive. Travel in one direction, no back in the future, to the future, now to the future. So the time is always positive quantity. However, K is negative number. But this logarithm is also negative. How do you know, Professor, K negative? Well, because you put in a calculator, no? Or you know, or you need to know the logarithm of the number less than 1 is negative when the base is greater than 1. Okay, don't worry about this. You put in a calculator something like that. Look, I put in a calculator something like that. This is my displays. I put ln, parentheses. Okay, ln. You put 2 over 7, 2 over 7. Close the parentheses. Divided by K. But actually, K is the letter K using in the paper. But in the calculator, I use A. Memory bar. And select A. Boom. Okay, I have the answer. This is A here. Press enter. And the answer is 18. Point 18. Let me see on the paper. Right here in the calculator. Yeah. 0.61. Yeah. 61. 62. Maybe. You depending in the test I specify how many digits we need. But this is the time. But the time is expressed in minutes. So this object cannot specification what's the nature of the object. It's cooling in 18.62 and the temperature decreasing from 100 Celsius degree to 50 Celsius degree in 18.62 minutes. Okay? Any question, right? Any question? No problem, oh yeah. You are in big trouble. I know, okay, this is complicated. In my opinion, this is the most complicated part. Always the word problems are complicated because you need to understand the thing you should do. You need to understand, but no. We have no infinity collection. We have the classic. Growth population, o sea, the interest, compound interest first, number 1. Growth exponential, decay exponential, and Newton cooling law. That's it, no more. There are more possibility of this, but no. Okay, let's move on. The time we have almost 25 minutes to start the review package. Review package. Do you have no question? No? Review package now. Let me try to find my computer review package. I sent to you one more time. The student can have no problem. So I sent the review package. The review package I have in my computer. Supposed to here. Okay, it's 3 documents. Let me download the first document. It's this. Boom. This is the question 1, 2, 3, 4, 5, 6, 7, and 8, and the review package. Okay, slow down. We have time to do everything, and you understand very well. Pay attention. Review package similar to the test number 4 on paper. Okay. Now, let me see. I need the question 1 and the question 2 is do the graph of the exponential. Let me start for the first one. The first one is f of x is equal 2 to the minus x. Actually, you can interpretation okay, this is equivalent to say 1/2 raised to the x because you know very well that 2 to the negative 1 is 1/2, no? This is clear, right? Entonces, I know that when the base is less than 1, our exponential, so remember we have two kinds of exponential. The classical exponential is like that, boom. And the other exponential is like that. This is decay, and this is growth. Okay, entonces we are in front the decay because the base is less than 1. It's important that you keep in mind. O sea, es, well, at the beginning you don't see very well, but the negative exponent indicate que es recíproca. Reciprocal is 1. Okay, let me try to bring, no this. I bring here. Let me see here. Okay, the rectangular coordinate system. Look, because my goal and the test I provide the rectangular coordinate system. Entonces, some students, I don't know why, doing the graph in another paper. No, you are doing in a paper of the test. Okay. Remember, in any exponential, the universal point is the point 0,1. Any exponential, doesn't matter if it's decay or growth, passing through that point. Entonces, the second point is 1, the base, pero the base is 1/2. Entonces, 1, 1/2. I suppose que es that point. Look. That point is the point. 1, 1/2. Because the base is 1/2 in this problem. And -1 is reciprocal. It's 1, -1, 2. This point is -1, 2. Guys, do you understand this or not? Let's do it. 3 points is enough to do the graph. However, if you want to additional 1 more point, okay, let's do it. -2 is a 4. So -2 is 4. Because, what's the reason? Because 1/2 raised to the -2, negative is reciprocal, 2/1 raised to the second power, and this is 4, no? 1 is 1, and 2 to the second power. Okay, and likewise, in positive 2, we have 1 over 4. Another point here would be 2,1/4. Okay, the connection of the point is like that. Approximately. And you need to know that the exponential approach to the axis but never touch because, and this no, this continue to infinity. Because we have horizontal asymptotes. So this is important. For me, it's super important. You are doing the graph without asymptote, it's incomplete. The one important part of the game is the asymptote. So you declare here horizontal asymptote at y=. End of story. And we are doing now the question number 1. Any question? Boom. Any question? You understand very well or no? You are capable to do any exponential. Regardless. Why horizontal? Why horizontal? because. Okay, let me try to explain. Why horizontal? Why horizontal? Let me try to explain. Because suppose que you any exponential, this one or any exponential. Suppose que you increasing, so suppose 1/2 raised to the, suppose que I want to increase in the x value. Suppose x equal 10, x equal 100, x equal 1000. Let's see what happens when you are doing this. This is 1, because 1 to the any power is 1. 2 to the 10 power. Okay, by the way, this is 1024. So you put it here, it's a small decimal. But so you put it here, of course, super small decimal. And so you put here a super small decimal. Entonces, this number, in order when you increasing the x, que es the idea and behavior of the horizontal asymptote, this approach to 0. Because this is small, very small decimal. And pero never touch. The exponential never is negative. It's totally illegal, that part. So, do you see or no? A ver, question. Come on. Do you see or no? Guy, remember, when I write, yes. Okay, this is, let me see. Who is KA? KA, who is KA? KA is Carolina. Ah, Kemily. Okay, do you understand, Kemily? Activate the microphone. Say yes, no. Come on.
Yeah.
Okay. I don't like this. Yeah. Okay, do you understand or no? Okay. Always any exponential contain, this is a part of the game, one horizontal asymptote at y equals 0. Logarithm no. Logarithm is another movie. But exponential always. So now, please, don't forget the horizontal, because you forgot, you have no full credit in that question. So I plot 3 points, 4 points, the point that you want. It's okay. 3 is the minimum that you need. And remember, the minimum, but the most important, in my opinion, is 0, +1, and -1. Remember the typical point in the exponential. Look, typical point in the exponential is universal is 0,1, 1 comma the base. In our question 1, the base was 1/2. And -1 comma reciprocal of the base. Okay, this is a typical point. 3 points is enough. Don't forget the horizontal asymptote, and that's it. Let's move on to question 2. Question 2 is similar. It's the same thing. It's super similar. But the base is 4. So it's f of x, number 2 question. Is f of x equal 4x. Wow, the base is greater than 1. The base is 4. Entonces, I am absolutely sure it is exponential growth. Look like that, 1. Okay, because greater than 1. Okay, but the typical point are 0,1, the universal, for any exponential, 1,4, because the base is 4, and -1,1 over 4. At least we have in my hand 3 points. Let's do it that. Plot that. Okay, using the red code. Universal point, 0,1. Boom, this guy. I plot that. 1,4. 1, I plot that. -1,1 quarter. 1 quarter is you take that segment, let me make it sum, and you divide by hand and half of the half. The -1,4 look like that. But this point is the point, -1,1/4. That point was 1,4 for this exponential, no? And this is universal for any exponential. And we're connecting now this point by the curve. Can look like that. Exponential graphic. Okay? Que es a curve. And this curve, I know que approach it, but never touch this axis because we have here horizontal asymptote. Always at 0, y equals 0. I declare here horizontal asymptote at y equals 0. Boom. Done. I don't know si in the test the base is 4 or is 3 or is 1/2 or is 1/3 or is 5 or is 7 or 1/7. Okay, you need to be aware for any situation. Are you aware or no? Question. Come on, question. Stop, question. I need to make sure that you understand, do by hand the graphic of course, the graph you receive in your home. And see, you are smart, you open Desmos and you do the graphic, you see, wow. Okay, it's another possibility, no? I don't know, okay, good. So to you, some people don't like, some people like by hand. Any question, guy? My question is, are you super aware how we can do that, the graph of the any exponential? Maybe decay or growth? Yes or no? I talk to you. I need answer. Yes.
Yes, sir.
This is yes, sir. This is okay. Okay. Okay, let's move on to the question 3. Okay, super easy in my opinion. Look. It's a classical problem. We're doing this and stop. No more. Okay. Number 3 is a word problem. It's a word problem. Okay, it's about. Look at that. The growth. So this word growth indicate me. Okay, it's exponential growth, no? Exponential growth. The growth of the population fit the exponential function p to any time is equal 346. This is the initial. E to the 0.05 t. And it's clear that k is positive. That is the reason it's exponential growth increasing, where time is the number of years since 1978. Estimated population in 2011. Wow. Let me see. Let's do in the graphical interpretations. This is the time. I suppose it's 10 years. And this is the population. I don't know if it's a human being or it's a rabbit or it's an insect population. At the beginning, we have 346, and the population increase. Exponential growth. Because K, when you see this number is positive, it's increasing. Si es negative, decrease. It's going up. Okay, entonces dice t equals 0. And t equals 0 is, in this problem, 1978. Yeah, I need to investigate what's going on at t equal, I have no idea, but this is the year 2011. Okay, entonces the direction of the time, you put in the calculator, 2011 minus 1978. Wow, it's 33 years. The duration of this event is 33 years. 33. Entonces now I plug in 33 in the equation, and you need to find the population in this time. Let's do it. This is the unknown. Okay, entonces population in 33 years. Look, population in 33 years is equal to 346 e to the 0.05 times 33. Okay, entonces I go back again to my calculator. Suppose que this is the display of my calculator. Entonces in the display of the calculator you put 346 times. Let's do it. 346 multiplication. Multiplication what? Exponential. I press second, the same key of the natural logarithm. I see in the display something like that. E power parentheses. And inside the parentheses, I put 0.05 times 33. 0.05 time after 33. And of course, close the parenthesis, no? To indicate what the argument is. And the answer is 1,801. And depende, ¿no? Si es population, obviously es 0.61502. Pero si es, for example, population of the something, entonces you express it to the near unit. O sea, es basically 1802. Es eso. Because this digit is greater than 5, you increase this. You run off. Okay? This is the answer. You follow me? You follow me?
Clear.
Super easy. I don't complicate your life. Okay? And online, yes. Go ahead. Question. Yes. What do you say? All right, in the chat. Let me see the chat. What do you say in the chat? Yes. Clifford is a yes. Okay. Okay, guys. So now I propose you stop because next problem is too long and complicated. Entonces now we continue. Let me see. Yeah. We continue next time. Okay, with the review packet. Remember, go ahead. Say again.
What's the difference between online?
Because online, I select more collection of the problem. So you see more miscellaneous problem of this. But you don't worry. When you don't understand something, this is classic from the teaching that part. The student sent me by email the screenshot of the specific problem. Be careful with this. Okay, because remember, and Alex is amazing. Alex, your problem is not equal to my problem. You say, no, professor, I don't understand the question number 8. The question number 8 is different to my question number 8 to another student. It's the same objective, but it's different number. You say, I cannot help like that. You send the screenshot. I solve your specific problem. I try to explain. I send the answer. I don't know, send the tutor service or after the class. You say, Professor, you can stay with me after the class. Yes, why not, right? Okay, but you need to ask. Okay, no, don't try to do a stupid thing because online is online. Online grade wrong. You are wrong. You have F. Okay. So I know that this part is hard to understand the word problem. So don't hesitate to ask me. The way I explained throughout the semester. Online, email me. You make a screenshot of the specific question. Okay, it's important. If you are doing a screenshot, are you safe? Because you don't save when you open again, your number change. Entonces ahí sobre, no, profesor, pero es different answer. Coño, pero es different number, right? Hall, do you follow me?
Yes.
Mr. Hall?
Okay.
Yes.
Another question. Come on, guys. We are a team and we work in the same direction. Okay? I succeed, see you pass successfully this class. See you fail the class, I am in big trouble. Therefore, I can help. I am willing to help anytime. Okay. Beautiful. Good night for everyone.